take a look. This is how we figure out what the pH is when we have quantities from a strong acid, strong base titration. Now, the important part here, I'm going to start off first with 50 milliliters. There we go, 50 milliliters of the 0.1 molar HCl solution. So what I'm going to do is I'm just going to simply find out the number of moles that I have of HCl first, because we're going to use that then to find out how much acid is left over or how much base is left over after I've done my calculations for A and B. So here's what this looks like. We know that molarity equals number of moles divided by volume, like this. So if I'm looking for moles, then all I have to do then is take number of moles equals, I don't know why I do that, concentration times volume. So my concentration, to find moles, my concentration is 0.10, okay, times the volume of this. Now the volume is the one thing I do have to change. 50.0 milliliters is actually, you guys know this, I have to change this to be liters, so it's going to look like that, 0.050 liters, like that. And then what I get then for the number of moles is, I think, let me just check quickly, times 10 to the negative third, which means that it's 2 zeros, 0.005, oops, 00 moles of HCl. Okay, that's actually our starting moles of HCl for our reaction. So that's important that we know what that is. Let's do exactly the same thing here. We're given the information of the same concentration of sodium hydroxide, which is pretty common, and then we're going to be adding that number of liters, well, milliliters. So let's go through exactly the same thing. Moles equals concentration times volume. So that means, not moles, yeah, concentration. So, my God, come on, poop for brains, times 0.0490 liters, like that. And what I end up with then will be 0.00490 moles. And that's the sodium hydroxide. Just like that. So notice that when, for the first part here, my HCl plus NaOH and what I get on the other side really doesn't matter, because what we're concerned about here is starting with 0.00500 moles and starting with 0.00490 moles, and when I subtract the two, .490, I know that's awful. I get 0 here, but here I get 0.00010 moles of HCl. And that's the important part. This is moles. Let me just take a quick look. When I go through this, there we go. If you want to follow along, this is page 733, has all the same information. So number of liters of the solution is additive, which means that I'm adding up the 50 milliliters. Let me put this right here. 50 milliliters plus 49 milliliters, like that, to give us a concentration of this number of moles divided by 0.990 liters, like that. And what I get then for that concentration is approximately 1.0 times 3 -3, like that. That's our concentration of HCl. That's close enough for us to deal with that. The pH for this then is equal to the negative log of 0.001, like that. and basically the pH is equal to 3. Good. That's the first part. Part 1, keeping it short.